Okay guys, so we're going to talk about zero exponents now. So we have seen exponents before, you've seen bases, but have you ever seen a zero exponent? And what does something equal if it's raised to the zero exponent? So we're tempted to say, well, it should be maybe 0. Or I've heard 4. If you have 4 to the 0, oh, that's equal to 0. And I'll say no. And then students will say, oh, well, maybe it's equal to 4. And I'll say no. So we're going to discover what should a zero exponent mean. What does a number raised to the 0 power equal? We're going to do that by looking at these tables. So I'm going to do this first one with you. You are going to tape this in your journal. This is going to be notes. So I want to look at this first table, and then I'm going to let you do the other tables, and we're going to come to a conclusion together. So look up here. We have 4 to the 4th power. Well, that means I take 4, and I multiply it by itself 4 times. 4 times 4 times 4 times 4. And I can work that out in the calculator and see that that's 256. So now let's do the next row. That's 4 cubed. Well, that's 4 times 4 times 4. And 4 times 4 is 16. 16 times 4 is 64. And if you're not sure, just put that in your calculator. Put 4 cubed or 4 times 4 times 4 in your calculator, and you should get 64. So then the next row is 4 times 4, 4 squared. And that's 16. And the next one says use 4 as a factor once. That's just one time, and that's going to equal 4. And then I come to the 4 to the 0 power, which I'm just not sure. That doesn't make sense. If I use 4 as a factor one time, it's 4 to the 1st power. Then it doesn't make sense that 4 to the 0 should equal 4. And it doesn't really make sense that it should equal 0 either, because there is something here. We wouldn't put 0. So you could put this in your calculator, and it's going to tell you the answer, but we're going to discover it over here. So I'm trying to look for a pattern. It tells me find a pattern. What's happening between these numbers? How do I go from 256 to 64? Okay. So let's use our calculator for that. Let's say we have 256. How do I get to 64? Well, you may notice over here, I'm multiplying by 4, 1 less each time. This is 4 4s, this is only 3, this is 2, and this is 1. So if I'm multiplying by 1 4 less each time, it's almost as if I'm dividing out one of those 4s. Oh, so 256 divided by 4 is 64. So I can see my pattern to get from here to here is to divide by 4. Well, let's try that again to go from 64 to 16. So if I say 64 divided by 4, do I get 16? I do. There's my pattern again. I'm dividing by 4. Okay, well, how do I get from 16 to 4? If I divide by 4 again, does that give me 4? Ooh, it does. Okay, I can see that my pattern is continuing. So guess what? In order to go from here to here, 4 to the 0 power, I'm going to have to continue that pattern. That's what mathematics is about. It's about finding a pattern and continuing it. We wouldn't break pattern. We're going to continue that pattern along. So that means that 4 divided by 4 is what I should do next, and that equals 1. So that only leaves that 4 to the 0 power must equal 1. Okay, that seems kind of strange, but that was my pattern. I'm dividing by 4 each time, and so I want to follow that pattern. So what I want you to do is pause the video now, and I want you to try these next two. See if when we have 2 as a base, and we have 5 as a base. See if you can find the pattern and continue it along, and see if every time when you get to the 0 one, if it equals 1. And then we'll come back together and we'll make some conclusions. So pause the video right here for a second and try those next 2 tables. Okay, so hopefully you came back and you did notice that every time you got to the 0 power, you got 1. So we're going to use that. And I'm going to tell you that mathematicians have solved this, and they have proved it, not just for 4, 2, and 5 as a base, but for every single number. It has been proven that anytime you have any number to the 0 power, it's going to equal 1. So 2 to the 0 is 1. We saw that in our table. What if you have some huge number, 1,517,230.567 to the 0 power? Guys, it's going to equal 1. Even if I have a variable to the 0 power, I don't know what number my variable represents, but it does represent some number. It's going to equal 1. It has to. Another number to the 0 power, it's going to equal 1. Look at this number. This is crazy. I've got 24 times some number that I don't know yet. I'm going to call him x squared times another number that I just don't know what it is yet to the 7th power. That's going to be some huge number, but that whole number is going to be raised to the 0 power. So that is going to equal 1. This is a really kind of neat idea that we can use in algebra, and it simplifies things with exponents really quickly. If you see something to the 0 power, you can go, ooh, that's got to equal 1. It's kind of a neat thing. And we get this idea by following this pattern all the way down. We have to continue our pattern, and so it works for every single number. Anytime we have something to the 0 power, it has to equal 1. So this is a rule you're going to have to remember. Anything to the 0 power is going to equal 1. You're going to need to remember that. I want to show you one other way that this is true. Let's say I have 7 cubed. Okay, we know that 7 times 7 times 7. Can I say that's 1 times 7 times 7 times 7? Is multiplying by 1 going to change my answer? No, it's not. So let's say we have 7 squared then. Well, that would just be 2 7s, right? 7 times 7, just twice. I'm going to put that 1 there. Notice it's not going to change it if I multiply by 1. So if I have 7 to the 1st power, well, that's 1 times how many 7s? Just 1 of them, because my power is 1. Well, then let's think about 7 to the 0, continuing our pattern. I've got 1 times, wait, how many 7s am I supposed to write down? None. I'm not supposed to multiply by any 7s because my power is 0, but I still have the 1 there, so it has to equal the 1 by itself. So this is just another way that we can show, using patterns, using math, anything to the 0 power is going to have to equal 1. It may seem like a crazy idea, but it is true. And like I say, if you can't remember it, you can always come back to your calculator. If you're on a test or a quiz or something and you can't remember what to the 0 power equals, just type in any number to the 0 power in your calculator. It's always going to tell you that it equals 1. You can't put a variable in, but you can put a number in. We could put some crazy numbers to the 0 power, and every time your calculator is going to tell you it equals 1. So that's kind of an easy way to remember what anything to the 0 power equals is 1, even if it's a variable. So we're going to use this idea as we continue along looking at exponents, so it's something we just need to remember.